Okay, welcome to week 5 of research methods. Today we are talking about psychological measurement. So let's go ahead and get started. An introduction to measurement. So we're going to talk about all these things. We're going to talk about variables, what they are, and how we measure them. We're going to talk about theories and constructs, which are important, right? That we know about those things so we can properly measure things, and operational definitions, which are related to theories and constructs. We're going to talk about reliability of measurement. What does it mean for something to be reliable? What does it mean for something to be valid? So validity of measurement. And that's about as far as we'll get today. And then on Wednesday, we'll talk about scales of measurement, modality of measurement, and other issues with measurement. Okay, so today it's just a chapter on measurement. Okay, so let's get started. Just to remind you about a few things that we talked about already, because this is all connected. The first step in the research process is to find an unanswered question that will serve as your research idea. Remember, all of you have to do a research project. Okay, so you must think of something that you want to study, something you want to look into, and you're not just going to read about it. You're going to actually design your own survey, do your own research, and report it in an APA-style paper. So find an idea, some unanswered question. It doesn't have to be an unanswered question. It could be something that somebody else has done. You just do it in your own way. Second step, form a hypothesis. Once you have an idea, some kind of question, right? Form a hypothesis. And then the next step, you need to use that hypothesis to develop your research study, okay? That will either support or refute the hypothesis. And when you do that, you need to think about variables. What are your variables? You know, what are you actually going to be measuring, and how will you measure them? That's what today's chapter is about. So let's talk about these variables. First of all, what are variables? Variables are simply things that vary. That's why they're called variables, because they vary. So characteristics or conditions. So the characteristics of people can differ, right? Whether they're male or female, young, old, you know, high IQ, low IQ, whatever it is. Conditions, you know, warm weather, you know, cold weather, a frustrating event, a relaxing event, all sorts of things that vary. That's what variables are. Okay, it sounds complicated, a variable, right? Because it's related to math and you think it's hard, but it's just, all it means is just something that varies. Okay, so a variable is something that can change or have different values for different individuals. Okay, and there could be a whole bunch of different things. A lot of things, probably most things vary. Okay. Things that don't vary, we call constants, but we don't really deal with those here in psychology. That would be something related to math and physics and maybe chemistry. Okay. So we need to evaluate differences or changes in these variables. Okay. And in order to do that, so you need to be able to define, in order to do that, right, in order to see if there's a difference in people or in whatever you're measuring, you need to be able to define and measure that variable. So how do you define that variable? What is it called? And how are you going to measure it? Okay. And in order to know, we need to know a little bit more about these variables. There's different kinds. There are some variables that are very easy to deal with and others that are not. Okay. So we have well-defined, easily observed, easily measured variables. So these are the ones that are easy to deal with. Examples would be height and weight, and those are not the only examples, of course, but those are some examples, right? Height is well defined, and it's just how tall you are. We can measure that with a ruler, with a measuring tape. Your weight also, we know what that is. Your weight in pounds or kilograms. It's just what you see when you step on a scale, right? So they're very easy to define. We know what they are. We can observe it very easily, right? We can observe your height very easily with a measuring tape, with your weight with a scale, right? Easily observed, easily measured. Okay, those will be easy. And then we have the kind of variables that show up a lot in psychology when you do a psychological experiment. Variables that are intangible, which means you can't really touch them. They're not so much physical as they are abstract, things that are mental, things that you have to imagine. Okay. An example would be motivation or self-esteem. What the heck is motivation? We kind of understand it. We have some idea because, well, we're alive, right? We know when we're motivated to achieve something, but what does it really mean? And how do you measure it? Or your self-esteem, right? You probably know if you have good, high self-esteem, but what the heck is it really? Does it mean happiness? What is it? How do you measure it? And even if we're talking about happiness, right? What the heck is happiness? So these are things that are very difficult to measure. Okay, they're intangible, they're abstract, they're mental, they refer more to ideas. Okay, measurement is more complicated for these things. The good news about these things that you're going to run into when you try to do your research project, the good thing about these is that there's been a lot of research done, and they have been defined, and ways of measuring them have been devised already. So you don't have to reinvent the wheel and try to define motivation for yourself and try to develop your own scale, your own measure. There are measures that already exist. And that's why you have to do research. You have to know what has already been done in your area. Okay, let's keep going. We need to know more about variables. In order to really understand variables, we need to know about theories and constructs. Now, you've heard about theories before. A theory is, to put it simply, it's an explanation of something, okay? It's a set of statements, really, okay? Set of statements that try to explain something, a set of statements about mechanisms underlying a particular behavior, okay? So a theory is something that explains something, is really what it is, okay? And it also allows us to make predictions about that thing. And theories help us define these things called constructs, okay? Hypothetical constructs is really what they are. A construct is a hypothetical entity, right? Something that we assume exists, right? And it's something that is created from theory and speculation. So it's something that's derived from theories. Like, for instance, if we have a theory about, about what motivates people, a theory about motivation, well, then motivation is a construct. It's something that we kind of thought of and defined and then try to measure, right? The construct is mentioned in the theory. So a construct is think of it as a construction. It's something that's been created. Motivation is not something we can see. We've had to kind of come up with a word for it and define it. That's a construct. Okay, these constructs are things that cannot be seen, but they're assumed to exist. Motivation, right? Self-esteem, happiness. These are things that we kind of assume exist. We think they exist, but we kind of had to construct them or create them. We've had to give them a name. And then what's harder is we have to think of a way to measure them, okay? So, but these things help explain or predict our behavior in theory, right? Theory talks about these things, and it tells us a little bit about what these things are, and perhaps, how to measure them, which is the next step, right? Yeah, these hypothetical constructs. Believe it or not, I'm going to throw out an issue for you, right? Lots of things are constructs, and they're hypothetical constructs, which means they're ideas. They are things that we have defined, we assume they exist, but do they really? Okay, I'll give you one example. Race is nothing more than a construct, okay? It's something that people came up with to distinguish among different people who look differently. But scientifically speaking, theoretically speaking, race is a meaningless construct. It doesn't really hold up to scientific scrutiny. It is absolutely meaningless. Now, ethnicity is not, but race is stupid. It doesn't really exist, okay? It's something that was used to distinguish among people who just look different on the basis of skin color, and that is much too simplistic to really account for the diversity we have. So it's a construct, and it's really rather meaningless one. People do differ, but they differ in more complex, meaningful ways than that, okay? But we still throw around race like it's something real, okay? Just to give you an example there, hopefully something that motivates you a little bit more to think about these things. But yes, we need to know about theories. Theories try to explain things, and then theories talk about constructs, things that we assume exist, motivation, self-esteem, intelligence, race, or whatever it is. And then from that, we get some ideas of how to measure things, okay? We get to these things called operational definitions, okay? An operational definition is really a definition that allows us to measure something. So it's a method for defining and measuring a construct. We need to define things in a way that allows us to measure them, okay? So we need to define self-esteem in a way that allows us to measure it. We need to define intelligence in a way that allows us to measure it. That's what an operational definition is, okay? So, theories lead us to constructs, and constructs lead us to operational definitions. And once we have the operational definition, then we can actually measure something for our study, okay? Remember, we have variables that cannot be observed, cannot be measured directly, things that we can't really see, and we assume they exist, and those things are called constructs, by the way. The way you measure them is the operational definition. So one example that I'm going to use over and over again is intelligence, right? That is a variable. That is something that varies, okay? Different people have different amounts of it. But it's also a construct. It's something we assume exists, but it's kind of hard to define and it's hard to measure, okay? But people have tried to define it. People have tried to measure it, which is why it's a good example. So if we're talking about an operational definition, defining intelligence in a way in which allows us to measure it, then one way we can define intelligence is your score on an IQ test. You can take an IQ test, right? And then your score is basically a measure of your intelligence. Okay? So the score is the operational definition of intelligence. Okay? Hunger can be operationally defined as the number of hours of food deprivation. Hunger can be defined as the number of hours that you've gone without eating, okay? The longer the time you've gone without eating, the more hunger you should have, right? The less the number of hours that you've gone without eating, the less the hunger. So we can operationally define it that way. We can define it in a way that allows us to measure it. But notice that hunger is not really hours, okay? But we're defining it in a way that allows us to measure it. So some of you are already seeing that there are some inadequacies here, inadequacies. There's some complications here, right? But we need to find a way to measure these things. And when we do that, we can run into problems that we'll talk about. So, and these problems, right? Well, that's what this part is about, limitations of operational definitions. So remember, an operational definition is basically a way to define something that allows us to measure it, okay? So one problem with an operational definition is that it's not the same as the construct itself. So the number of hours you've gone without eating, is that the same as hunger? The number of hours is not hunger, right? But it allows us to kind of indirectly, measure hunger because those things are related, okay? Or IQ, right? IQ, right, is your operational definition for intelligence. Is it really the same as intelligence? Your IQ is a score on this test that somebody created. Is that the same as intelligence? Probably not. Okay, it's just a score. It's something that relates to intelligence, hopefully, or we think it does, or we want it to. Whether it does, we'll talk about. Okay, but that's a problem with operational definitions, is that it's not the same thing as the thing we're trying to measure. It is just a way for us to define it that allows us to measure it. And often it's what we're trying to do is actually very different from what the real thing is, right? A score on an intelligence test, a score on an IQ test is not the same thing as intelligence. The number of hours you've gone without eating is not the same thing as hunger, but it's a way to measure these things. So that's one problem. It's not really the same thing. An operational definition is not the same thing as the actual thing that we're trying to study, but it's just a way to approach it, right? A way to try to measure it. Other concerns about, or other limitations about operational definitions is that operational definitions often leave out important components of the construct. When we define something in a way that we're trying to measure it, it often leaves out important things, okay, that actually help define what the construct is. So I'll give you an example. So you take an IQ test, right? That's the IQ test is the IQ is the operational definition of intelligence. Well, IQ tests, as you guys know, right? If you heard anything about them at all, don't really measure creativity. They don't really measure social skills. They measure a bunch of other things. So the point is that, the operational definition of intelligence, IQ, leaves out things that are important for intelligence. Yes, social skills matter. So does creativity. So do a bunch of other things that the IQ test doesn't really capture. Okay, so operational definitions leave out important things, important components of the actual construct, important components of the thing we're trying to measure. And we have the opposite problem. Operational definitions often include extra components, extra things that are not part of the construct. If you look at IQ tests carefully, you'll see that they include questions related to culture. It's just about impossible to come up with a test that does not reflect the culture of the person or the people that created it. It's just impossible, because what is knowledge that measures your intelligence is knowledge that the people who make the test think is important. And that always relates to culture. No matter what they do, it always relates to culture. Okay. But your culture really should have nothing to do with your intelligence, right? Intelligence should be something that we could measure, no matter what culture you're a part of, right? It shouldn't matter. But what you actually find is that almost all, practically all IQ tests are culturally biased. If you are not a part of the culture for which it was created, your score is going to be lower. I mean, how would you like to take an IQ test developed by the Chinese, okay, as an American? Probably would not be a good idea for you. The test would probably show you probably not that bright. Well, it's the same thing for those other cultures, right? You know, if you have someone who comes from primarily, Spanish-speaking country, or, from some other country, from China or some Asian country or African country, and they take an IQ test developed for Americans, it wouldn't be fair. That's a problem. The tests always reflect the culture, that they're derived from. That's just the way it is. So these are problems that we have when we try to measure these things. And we try to come up with these operational definitions. Now that we've talked about some of those problems, let's talk about how we can then determine if we have an operational definition, or a way to a measurement that is valid and reliable. So we talked about how do we define things. We talked about what some of the problems are, and now, well, how do we know if we have a problem? Okay, so let's so we need to talk about reliability and validity. So researchers have developed two general criteria, two ways for evaluating the quality of any measurement procedure. So if you really want to know, well, do you really have a good IQ test or a good measure of mood or motivation or whatever it is, then you have to know about something called reliability and validity. Because yes, these measurements have problems, as we have seen. So how do you know if you have a good one? How do you determine this? So that's what we're talking about. So first, we're going to talk about reliability because it's a little bit more simple. But in this class, we're going to make it a little bit more complicated because it's not a Psych 101 class. But in principle, reliability is simple. Okay. So reliability is the ability or the consistency of the measurement procedure, of the measurements produced by a specific measurement procedure. All right, let me tell that to you guys in a way that is easy to understand, a way that makes sense. Reliability is simply how consistent a measurement is. That's all it is. So how stable it is, how consistent it is. So for instance, if we measure your height with a ruler, let's say, and you're 6 feet tall, let's say you're exactly 6 feet tall. The ruler says you're 6 feet tall, right? We measure your height once, we measure it again, we measure multiple times, and the ruler always says that you're 6 feet tall. Okay, that is a reliable measure. It is stable, it is consistent. That's simply what we mean with reliability. And like I said, when we're talking about things like height and weight, those are things that are easily observed, easily measured, okay? So there are some very reliable measures for those things, like a measuring tape, a ruler. Those are reliable measures for height, or scales, or can be reliable measures for weight. Some scales are less reliable than others, but assuming you have a good one, it will be pretty reliable. Okay, that's simply what we mean by reliability. It's just how consistent is a score, right? How consistent is a measurement, okay? Now, here's a little bit something to complicate a little bit. Now, when you actually measure something, the measurement score, right? The score you get is actually has two parts. One is the true score, right? What the measurement actually is, and another one is error, okay? And that error could come in different forms, okay? Because it's hard to measure things perfectly. There's always a source of error. And here's, your sources of error over here. One source of error can be observer error, right? The individual who makes the measurements can introduce simple human error. Like, let's say somebody measures your height with a measuring tape, okay? Well, what happens is that they use that measuring tape and they don't quite stretch it out enough, right? It's a little bit wrinkled or something. They don't do a good job. And therefore, they get a certain height, and then there's some error. Let's say there's an extra inch in there because they, Well, actually, in this case, let's say there's a missing inch, right? It says you're 5'11" rather than 6 feet tall because they didn't really stretch out the, the measuring tape enough. Okay, or it could be the opposite. Okay, let's say, actually, no, wait, I was right the first time. There's an extra inch because they didn't measure. So it says you're 6'1" rather than 6 feet because they didn't stretch it out enough. Or let's say that they stretched it out too much, right? They stretched it a little bit because it's one of these, let's say, measuring tapes that is made out of plastic, an elastic kind of plastic, and they stretch it out too much. And in this case, it says you're 5'11" rather than 6 feet tall. That extra inch is error. And in this case, in this example, it's observer error, or it's human error. It's an error that somebody made when they used the measuring device. That's what I mean by observer error. There's also error that's introduced because of environmental changes, because it's difficult to obtain the ideal of identical circumstances. Now, here's the thing. Environmental changes. Now, with things like height and weight, environmental changes, well, I mean, they don't make much of a difference as long as you're on the same planet. Well, there could, they don't really make much of a difference. But when you're talking about things like, say, like motivation, right? Or let's mention self-esteem instead. When you're talking about something like self-esteem, the environment can change and affect your self-esteem. So let's say that, one day, that it's a nice sunny day. And because of that, the measure of self-esteem says that, you're feeling pretty good about yourself. Another day, the weather's awful, okay? And they measure self-esteem on that day. And, the measure says that, well, your self-esteem is a little bit lower on that day. Those are environmental changes. They can cause, sources of variation, or they can cause basically error, sources of error, okay? Extra measurements, they can subtract or add to the true measure. You also have participant changes. There are changes in the participant themselves, okay? The actual person, okay? Like, let's say the degree to which the person is focusing, right? Let's say the person takes this, this self-esteem test. And one day they're very focused, they do a very good job, they take it seriously. And, and then it says, this is your self-esteem. On another day, let's say they're very distracted and they answer the questions without really thinking much about them. You'll get a very different measurement, okay? And that's a source of error as well, but this time it's due to the participant, okay? So whenever you measure something, you have error, okay? It's never perfect, okay? Now, sometimes they get, there's measurements that have to do with physics, physical things, they can measure very, very precisely. There'll still be some error, but it's very close to perfection. But when it comes to things that are psychological, your mood, your intelligence, your self-esteem, your motivation, those things are hard to define, they're hard to measure, and they're gonna have more error. Okay, it's just the way it is. It's psychological. They're more difficult variables to deal with, is what I'm saying. Okay, so how do you know if you actually have a good measurement, right? Well, one thing is you have to demonstrate that there is consistency or reliability of measurement. We mentioned that, right? Now we're going to talk about how you determine that. Okay, so is your measure consistent? Okay, a measure that is reliable, that's consistent, right, is like a good ruler. It always gives you the same score or nearly the same score. That's what we mean by reliability. It's reliable, something you can count on. So reliability is when two scores, right? Let's say one score from a new measure and one score from a well-established measure are, presented. Well, here's the thing: you have to have two scores when you want to determine reliability or consistency. You have to take two scores, okay? Two scores for each person, right? So you measure one score. Let's say you measure somebody's height once, right? And then you measure somebody's height a second time. And then you want to see to what extent those scores are consistent. So two scores, let's say one from a new measure, right? The one you've taken most recently, and another score from another measurement, one you took, let's say last week, right? You represent them on a scatter plot. Remember the scatter plot from 101, right? It's used to determine correlation. Well, with correlation, we can determine consistency or reliability. So if you plot the scores, right? Let's say you give somebody a test 1 week and then you give them a test the second week. On another week, you check to see to what extent the scores are related. Okay. Now you need to do this for more than one person to get a correlation. Okay. But if you have a positive relationship, Okay, that means the two measurements change together in the same direction. If you have a positive relationship, that means that people tend to score similarly, okay, on the first test, let's say, and also on the second test. That's a positive relationship. So if they score high, let's say the first time, they'll score high the second time. Or if they score low the first time, they also score low the second time. That's a positive correlation. So the scores basically are either go up together or down together. It's a positive relationship, okay? If you have a negative relationship, that means the two measurements change in opposite directions. That means that the first time you took the test, let's say you got a high score, and then the second time you got a low score. And it seems to be that way for a bunch of people, because you're going to do this with multiple people. You're going to check the scores with multiple people. That would be a negative relationship. That would not be reliable, by the way, okay? When you want to demonstrate reliability, consistency, you want to show a positive relationship. You want to show that the first time you measured this person was 6 feet tall. And the second time you measure this person, the person is still just about 6 feet tall. That's a positive relationship. If you have someone who is short, who scores lower, let's say this person is 5 feet tall the first time you measure them. The second time you measure them, they should also be around 5 feet tall. That's a positive relationship, okay? That means the scores tend to be consistent. That's really what that means. That's the way you show reliability, consistency. You have to measure things more than once. And if the measurements are basically consistent, that means that they are reliable. So more about determining consistency, right? You should know something about this already from Psych 101. So you determine the consistency of a relationship by computing a correlation between the two measurements, okay? So yes, we use correlation to determine consistency. And what you want is a consistent positive relationship, a correlation near +1, okay? So if you have a consistent positive relationship, that means your test is reliable, okay? So a consistent positive relationship means that your score is near 1. And we already said that consistency means that it's reliable, okay? So that's what you want. And believe it or not, these IQ tests that I've been mentioning, they are very, very reliable, very consistent. You can take that IQ test once, take it a second time, take it a different week, a different month, and you'll find that you'll get a very similar score. The reliabilities are very close to +1. The reliabilities are something like 0.96, 0.97, 0.98. I mean, they're almost perfectly consistent. Okay, so these tests are reliable. Okay, that means they measure something consistently. If you have a consistent negative relationship, that means the correlation is near -1. A consistent negative relationship, well, that would not be good. That means the first time you take the test, right, let's say you score high, and then the second time you score low. That's not really what you want. That's not consistent. And if you have an inconsistent relationship, that means you have a correlation near 0. That means you take the test once, you take it a second time, and the scores always differ. With a consistent negative relationship, the scores are always opposite. One is high, the other one, the next time it's low. With an inconsistent relationship, correlation near 0, that means they're all over the place. They could be high, high, low, high, right? Low, low, and they could be all over the place. That's an inconsistent relationship. The point is that you want a consistent positive relationship. You want the first score and the second score basically to be nearly identical. That's how you show that something is reliable. I know I'm complicating things a bit here by talking about correlation, but correlation is actually simple, and you need to determine the correlation between measurements in order to show that there's consistency, that there's reliability. If you remember from Psych 101, right, on the upper left there, we have a positive relationship. When you plot the points, right, they tend to cluster around a line with a positive slope. Okay, that's what you want, right? You want a consistent, reliable relationship. That means high scores the first time correspond to high scores the second time. Okay. If you have a negative relationship, the points cluster on a line that has a negative slope, and that's like what we have on the upper right. Okay, and that means that if you score high the first time, you score low the second time, and vice versa, right? If you score low the first time, you score high the second time, and that is a negative relationship. That is not what you want, okay, when you're trying to demonstrate reliability, right? You want the scores to be consistent, and that means that you should have a positive relationship among the measures. No relationship means that the points are all over the place. That's what you have on the lower graph there on the page in the middle there. The points are all over the place. There's no real pattern there. That's also not good. Okay. That means there's no consistency. That means there's no reliability. You want your test, your measure to be reliable. If it's not reliable, you should not be using it, okay? If it's not reliable, if it doesn't measure something consistently, you don't want to use it. Think about it this way. If you want to measure somebody's height with a ruler, and that ruler, the first time it says you're 6 feet tall, and then the next time it says you're 5 feet tall, and then it says you're 4 feet tall, and then 7 feet tall, that would be a really stupid ruler, right? You should not use that thing. It's worthless, okay? So measurements, at the very least, have to be reliable. Otherwise, they're completely useless. Okay, so we have to show that they are reliable by measuring things multiple times. And then we show that there's a pattern there, that we have a correlation in the scores that are pretty close to +1. And for the most part, almost all those measurements, those IQ tests, those measures of self-esteem, all those that have been published, they're pretty reliable. Okay, that's why they've been published and they're well established. Okay. Now, there's different types, there's different ways to measure reliability. Okay, there's not just one way, there's different types of reliability. The one I've been talking about, which is the simplest one, is test-retest reliability. That's when you compare the scores of 2 successive measurements of the same individual and correlate the scores. All right, that sounds complicated, but test-retest reliability is simply this. Okay, you measure people once, you measure them a second time, and then you check to see how those scores correlate, whether they are consistent. Test, retest, right? Take the test once, take it twice. Okay, do that for a bunch of people, okay, and you can find if the test is reliable or not. Just measuring one person is not going to be enough, okay? Just because the person scores, you know, it gets a similar score the first time and the second time doesn't mean it's reliable. You can't determine reliability with one person. You have to use multiple people, probably hundreds, okay, to determine reliability. Okay, that's test-retest reliability, the simplest form of reliability. So the measure, if the measure produces an identical or nearly identical, if the measure produces identical or nearly identical scores when it's used repeatedly to measure the same individual under the same conditions, that means you have a high positive correlation. You're getting nearly the same score every time. People who score high continue to score high. People who score low continue to score low. People who score in the middle continue to score in the middle. They get nearly the same score every time. That means you have a high positive correlation. That is a reliable measure. And you demonstrate the reliability by using test-retest reliability. So an example here, an IQ score gives you 107, right? The first time you take it, let's say you're person A, right? You get 107 the first time you took it. And then you take it a week later, and this time it gives you 106. That's almost nearly the same score, very close. Or maybe it's 105, maybe it's 108. It's pretty close. It's almost the same. Okay, that would mean that it's reliable. That's test-retest reliability. Now, you wouldn't just do it with one person, okay? You would do this with, you know, multiple people, hundreds of people to show that your test is really reliable. Now, the good news is you guys really don't have to do this for your measure, okay? Because you really should be using measurements that are already established. So if you really want to, if you're interested in self-esteem, if you're interested in motivation or intelligence, whatever it is, you need to go out there and read the research reports, find measurements that are already well established, and use those so you don't really have to do this yourself, because you don't want to do this yourself, okay? It would really make the project take a lot longer, okay? And you don't really know how to do this yet, okay? We're just talking about it. You could also demonstrate what's called internal consistency, okay? Another form of reliability is called split half reliability. So all you do is you split the test in half. Okay, and you give participants the first half, and then sometime later you give them the second half. Okay, and they take the first half and the second half, and then you see to what extent the scores on the first half are similar to the scores in the second half. That's split half reliability. Again, you want high positive correlations. You want your correlations to be near +1, not -1. Okay, not negative. That wouldn't help you, and not correlations near 0 either. You want high positive correlations. So you can look at the first half of the test versus the second half. You can take the odd questions on the test and compare those to the even questions. Okay, that's split half reliability. As a matter of fact, you know what? You don't even have to have your participants take the test, take the first half at one time and the second half at a different time. You could just have them take the entire test And then you can separate the scores for the first half and the second half. Separate those questions and look at them to see how they correlate. Or you can separate the odd questions from the even and look at it like that. So you don't have to have the participants take it at different times. Okay, you just look at the odd versus the even, the first half versus the second half. So that's split half reliability. Split the test in half and check to see the extent to which the scores agree. There's also inter-rater reliability. Now, inter-rater reliability refers to basically, observations, okay? That has to do with observations. Inter-rater reliability is agreement between two observers who simultaneously record measurements of behaviors. So when you're doing an observation, you're observing behavior in the real world. It's a good idea to have more than one person observing the same situation, and they make their measurements, their recordings, right? And and then they record those things, and then when they're done, you can check the extent to which their scores are similar, and you can determine the inter-rater reliability, the extent to which their measures are consistent, whether they're how similar they are. And again, you want the scores to be very similar. You want a high positive correlation, right? You want them to, observe things very similarly and measure things similarly. That's inter-rater reliability. Okay, that refers to when you're doing an observation. Let's keep going. Now let's talk about validity. So one thing is to show that a measure is reliable, that you get a very consistent score, when you use the measure multiple times. And another thing to determine is that it's valid. It is much harder to establish validity, okay? To show that something is actually measuring what it's supposed to measure. So these IQ tests that I've been mentioning, they're all highly reliable, okay? You got reliability scores that are very close to 1, 0.96, 0.97, 0.98, like I said, very reliable, okay? So those tests are measuring something. Now, to determine what they're measuring, then you have to think about validity. So the tests are measuring something, but are they really measuring intelligence? Okay? If they really are measuring intelligence, that means they are valid. So something can measure something consistently. That doesn't necessarily mean it's valid. Determining validity is a separate question, okay? So to establish validity, the measurement procedure must accurately capture the variable that it's supposed to measure. So in order to have validity, the measurement must actually measure what it's trying to measure. So to have validity for an IQ test, that means the IQ test really has to be measuring intelligence. Is it really measuring intelligence? Okay, well, that's the thing that has to be determined. And that is very hard to determine. Validity is hard to determine. So does an IQ test really measure intelligence accurately? Or is it measuring something else? Is it merely measuring cultural knowledge? Is it measuring privilege or something else, right? Because we always have the fact that those who are better off always score higher on the IQ test. Those that are better off economically. Does that mean they're more intelligent? Or does it mean that they have certain advantages? And maybe that's what the test is measuring. Or is the test just measuring culture? Because as we said, right, when it's your culture, right, that test is based on, you'll do better. If it's not your culture, you'll do worse. Okay, so it's hard to determine validity, but we're trying to determine if it's really measuring what it's supposed to measure. Okay, is the IQ test really measuring intelligence? Is the measure of self-esteem really measuring self-esteem? Or is that measure of happiness? Let's say you're interested in happiness. Is it really measuring happiness? What the heck is happiness? How are they measuring it, right? It's hard to determine validity, but there are ways to do it. Here's one measure of validity. Here's one way to look at validity. You can look at the face validity of something. Face validity is the simplest and least scientific way to measure validity. With face validity, what you're looking at is whether a measure superficially appears to measure what it claims to measure. In other words, when you look at the test, it appears to be measuring, whatever it's claiming to measure. So if you look at an IQ test and you look at the questions, you see questions in there about logic, about knowledge, about memory, about a whole bunch of things. And you look at them and say, well, yeah, this looks like it's related to intelligence. That's face validity. Or you look at a measurement that's measuring happiness and you look at the questions and you say, yeah, these seem to be about happiness. That's face validity. It looks like it's measuring the right thing. That's face validity. It's the simplest one, the least scientific. Okay, it just looks like it's measuring the right thing. And you don't even have to use any statistics here, right? You don't have to look at any correlations. It just looks like it's measuring the right thing. That's face validity. Now, there's other forms of validity that are harder to establish. There's also concurrent validity. That means that the scores obtained from a new measure are directly related to scores obtained from a more established measure of the same variable. So let's say you're trying to establish your own intelligence test, okay? If you want to show that your test is valid, one thing you have to do is show concurrent validity, right? You have to show that the scores on your test, right, the new test you're trying to say that you're trying to develop, that the scores on that test basically are just as good as the scores on another test, or that they are similar to the scores on another test. So you can give, let's say, your IQ test to a bunch of people, let's say 100 individuals, and you also give them, you also give an IQ test that was developed, 20 years ago to those same individuals, and then you check to see the extent to which the scores are reliable. So how did the people score on the old test versus your new test? If the scores are similar, that means you have a high positive correlation, and that means you have concurrent validity. So if there's a positive correlation between scores on the new test of intelligence and the more established one, you have concurrent validity. Okay, that's concurrent validity. There's also predictability. Predictability is something that's more useful in my opinion. Predictability means that the scores obtained from a measure accurately predict some behavior or something about the theory, something the theory says it should predict. Predictive validity means that the test actually predicts something that should be related to the actual thing you're trying to measure. Like an IQ test, let's say, should predict high school GPA. So if the IQ test says you're intelligent, then we should be able to predict that that person that has a high IQ also probably has a high GPA, right? If the people who really have high IQs are actually more intelligent, then they should be doing better in school, better in high school, better in college. And for the most part, the IQ tests do show that. But I will tell you that there's plenty of people who are very smart and who fail all their classes because they don't give a damn. Okay, they're intelligent, but they have very low GPAs. Okay, but for most people, that's why we test more than one person. That's why we test a whole bunch of people. Okay, we determine the extent to which the IQ test actually predicts GPA, or high school GPA or college GPA, or the extent to which it basically basically correlates with these things with GPA. Okay, if it can predict that, that means it correlates. We can predict that those that have a high IQ probably also have a high GPA. And when we check their GPAs, we'll find out that that's true if the test has predictive validity. There's also construct validity. Construct validity is a little bit harder to understand. Construct validity is when the scores, right, obtained from a measurement behave exactly the same way as the variable itself. So this is hard to understand. So it's when the scores basically vary the same way you would expect the actual variable, the actual thing that you're interested in, when it varies the same way. So for instance, let's say you're trying to measure intelligence. Well, we know something about intelligence, that we know that as children get older, they get more intelligent up to a certain point. Okay, children are born, they don't know very much. And then they start learning language, all sorts of things, and they get smarter and smarter up to a certain point. And become more and more intelligent up until adulthood. And then at some point it levels off, and then probably declines in old age, because in old age, things start to go bad. Your brain starts basically deteriorating to some extent. So here's the thing. The IQ test scores, right, should increase as children get older, if you give them the same kind of test, let's say, and then eventually level out and then decline, right? If we measure people, if we give this IQ test to people of different age, those that are very young, that don't know very much, are probably not gonna get too many questions right. They're gonna have a low IQ, according to the test, right? And as they get older, you'll probably see that they know more, the IQ is higher, and then when they get much older, you'll probably see them score worse again, and it begins to decline. That means that basically the variable or the thing the construct or your measurement behaves the same way as the actual thing itself. That's construct validity. So it behaves the same way. Okay, and that's a little bit hard to understand. I get that. Okay. Now, convergent validity. Convergent validity makes a lot of sense. Okay, this one's easy to understand, but very useful. Convergent validity is when there is a strong relationship between two scores, right? Between two scores obtained from two different methods of measurement. Okay, let me explain. Okay, convergent validity means that the scores converge or they come together. So let's say basically you measure somebody's IQ with somebody's intelligence with an IQ test, right? It says they have high intelligence. And then you also basically, check, let's say their GPA, and they have a high GPA. And then you also ask the counselor, is this person intelligent? And the counselor say, yes, this person's intelligent. That is all convergent validity. You have different things that suggest that this person is intelligent. So different measures converge in telling you that this person is intelligent. So the IQ test suggests that person A has high intelligence. The teacher also says the person A is intelligent. So does the counselor, so does the GPA, right? There are lots of things that tell you that person is intelligent. Now, let's make this a little bit more fun. How do you know if you're dealing with someone, let's say you have a person, right, that you're dealing with, and that person is very difficult, right? That person is, an ass, so to speak, really difficult, awful person. How do you know if that person is really awful, or maybe it's just you who's awful? How do you know? Okay, here's the thing. Let's say you don't get along with that person. That person treats you really bad, right? Well, talk to other people. If other people say, yeah, that person's awful, he's always giving me a hard time, and other people say the same thing, then you have multiple sources telling you, yeah, this person is awful. Then that's convergent validity. That means that person probably is awful. That person probably is difficult, hard to get along with. Okay, you have multiple sources telling you the same thing. That means they're probably onto something. That means something is probably really happening. But if it's just you who thinks that person is difficult and other people think the person is wonderful, then guess what? Maybe you're the one who's difficult and not that person. Okay, so you look at multiple sources of evidence, and if they agree, there's probably something going on. There's probably some truth to that. That's convergent validity. There's also divergent validity. You also want to show divergent validity with your measurement. Okay, divergent validity is when you show little or no relationship between the measurements of two different constructs. So divergent validity is the opposite of convergent validity. It's when things diverge. So with convergent validity, you want to show that different things, different sources of information, basically relate to your measurement, that they said the same thing. With divergent validity, you want to show that your measurement is different than some other thing it should not be related to. So let's say the IQ test, they're often criticized that the tests don't really measure intelligence, that all they're measuring is cultural knowledge, all they're measuring is culture. Well, if you want to show that your divergent validity with that IQ test, right, you have to show, that IQ test, for instance, the scores on that test are not related to the scores of a test that measures culture. So you can have a test that measures culture, right? Like how much cultural knowledge you have of a given culture. And then you can have an IQ test, that is basically derived from that culture. And you can check the scores on the IQ test for a bunch of people and the scores on the culture test for those same people. And if there's really no correlation, no consistency there between the two measures, that means the IQ test isn't really measuring culture because the scores are not very similar. That's divergent validity. So you want to show that. You want to show that, no, my IQ test is not measuring culture. It's actually measuring intelligence, right? And look, here's a test that shows you that it's not really the same thing as culture. Or that it's not the same thing as privilege. You can have a test that measures privilege, right? You can look at income, where they grew up, all sorts of things. And you could also have the IQ test and see if there's some relationship there. I guarantee you there is, though. The relationship between IQ and privilege is high, okay? And culture and income and all those things. So it's hard to show divergent validity, but what you're trying to do there is you're trying to find evidence that the measurement that you're looking at is not the same thing as something else, okay? That not the same thing as something else. You want to show that your IQ test is measuring intelligence and not culture. Or you want to show that your measure of self-esteem is really measuring self-esteem but not necessarily happiness, because that's a different construct. So you need to show divergent validity. So divergent validity, when you plot the points, right, for the different measures, for different people, for the test for different people, you want to show, you want to see on the scatter plot that there's no relationship there, a correlation close to 0. Now, what is the relationship between reliability and validity? Okay, so how do you know if you have a good measure? We talked about reliability, we talked about validity. So here's the thing, and this confuses some people, so I try to put it here as simply as possible. Reliability is a prerequisite for validity. That means, as it says there, that if a measurement is not reliable, it is not valid. If something doesn't measure something consistency, it cannot possibly be valid. Think about it. I mentioned this before. If you have a ruler, and that ruler is supposed to measure height, but that ruler says you're 6 feet tall one day, and another day it says you're 5 feet tall, another day it says you're 4 feet tall, another day it says you're 10 feet tall, right? That ruler is not reliable. That means that ruler can't possibly be measuring anything that's valid. It's not even reliable. It doesn't even measure anything consistently. If it's not consistent, okay, it cannot be valid. However, if you have a measurement that is reliable, if you have a measurement that does measure something reliably, consistently, then it may be valid or it may not be. Okay? So let's say you have a test of intelligence. It measures something very reliably, right? All these measures of intelligence that are written about, that are published, all are very reliable. Like I said, they have correlations or reliability scores near +1, 0.98, 0.97, 0.96. They're all highly reliable. But are they valid? Some people say they are valid, that they really are measuring intelligence, and other people say no, they're not valid. They're just measuring culture, they're just measuring privilege. They're measuring basically socioeconomic status, which means whether you're upper class or middle class, and that they're not valid. So if you want to show that something is really measuring what it is supposed to measure, at the very least, it has to be reliable for you to even have a chance to show that it's valid. And then if it is reliable, then you might show that it's valid, or it might still turn out that it's not valid. Okay? I'll give you an example with the, I can give you, let's say, a psychology test, right? The test of, test that's supposed to measure, your knowledge of psychology. And the test can be very reliable. You can score nearly the same every time you take the test. But then when you look at the test, so it's very reliable, but when you look at the test, you see that the questions are all about history. So my test is reliable, but it's not valid. It's not measuring psychology, it's measuring history. So you see how you can have something that's reliable, but still not be valid? Just like with the intelligence test, they can be very reliable, but are they valid? People question the validity. A lot of people agree that they're valid. Some people say that it's not valid. It just depends on which side you're on, right? If you're basically on the side of, the people who basically the intelligence test said that you're very smart, and there's a whole bunch of other people who say the test is not so smart, right? Well, that kind of determines whether you believe they're valid or not, but not just that. It's other things as well. If you're part of the culture, part of the privilege, you're going to say, yeah, these tests are damn well valid, right? If they say I'm very intelligent, and there's other people who don't have very much, it says they're not so intelligent. Well, that's why they don't have very much, because they're not intelligent. Okay? So people argue about these things. Validity is harder to establish, but in order to even have a chance of establishing validity, you have to have reliability. If you don't have reliability, you cannot have validity. But just because something is reliable doesn't mean it's valid. Okay, and we will stop there. Let me stop recording.